In this video, we want to prove whether the following is a relation or not. So first, let's look at a couple examples. So is 3, 6, R 3, 5? Well, here A is 3, B is 6, C is 3, D is 5. So we plug it into the equation. We see that 3 plus 5 is 8, 6 plus 3 is 9. Those are not equal, so this is not a relation. Next, we look at 1, 1, R 3, 5. We plug it into the equation. We have 1 plus 5 is equal to 1 plus 3. Well, that means that 6 is equal to 4, which is not true. So that is not a relation. Okay, now let's prove R is an equivalence relation. Let's consider A and B to be natural numbers. So let's first look at the reflexive property. Let's look at AB and BA. If we look at AB and BA, we plug it in, we get A plus B is equal to B plus A. Well, this is true because addition is commutative. So R is reflexive. Let's look at symmetric. So let A, B, C, and D be natural numbers. Now let's look at AB and CD. That's just going to be A plus D is equal to B plus C, which we can rewrite this by putting the B plus C first in front. So this B plus C just comes out in front here, and then the A plus D comes out after. And so B plus C equals A plus D by definition of this relation is CD R AB. So then R is symmetric. Now let's look at transitive. We'll let A, B, C, D, E, F be natural numbers. And let's first consider A, B, R, C, D. That is equal to A plus D is equal to B plus C. And now C, D, R, E, F is C plus F equals D plus E. Now let's add these two together. So we have A plus D and then plus C plus F is equal to B plus C and then plus D plus E. So notice that we have a D and a C on the left here, C and a D on the right. Those are going to cancel, and so we're left with A plus F equals B plus C, which is the same thing as A, B, R, E, F. And so if we follow this logic, we have A, B, R, C, D, and that implies A, B, R, E, F. So this is transitive. Okay, next. So that proved that it's an equivalence relation, since we proved it was reflexive, symmetric, and transitive. Now let's look at three elements that belong to the equivalence class of 1 and 2. So here A is 1, B is 2. So let's look at C and D. Okay, so that's what we want to find here. So if we plug it into that equation, we have 1 plus D is equal to 2 plus C. And if I subtract both sides by 1, I get D is equal to C plus 1. So if C is 1, D is 2. If C is 2, D is 3. If C is 3, D is 4. Now if we look at the equivalence class, when A is 1, B is 2, we can let C equal 1, which means D is 2. We can let C equal 2, which means D is 3. Or we can let C equal 3, and then D is 4. And so those are my three elements.